Hello students, welcome to the lecture session. This is the second video of module 4, that is curve fitting and statistical methods. In this video, I am going to explain about the further correlation coefficient which we have already given the introduction about the correlation and also the statistical methods. So to begin with, Pearson's coefficient of correlation, the formula for that is summation R is equal to summation of xy divided by n sigma x sigma y, where capital X is deviation from the mean, that is x implies x is equal to x minus of x bar, where x bar is the mean, and deviation from the mean y, that is capital Y is equal to y minus of y bar, and sigma x is standard deviation of x series and sigma y is the standard deviation of y series, and n is the number of values of the two variables. Alternative formula for R. What is the alternative formula for R is, this is the R. So R is nothing but summation xy divided by root of sigma x square into sigma y square, or R is equal to n sigma xy minus sigma x into sigma y divided by root of n into sigma x squared minus sigma x the whole square into n into sigma y square minus sigma y the whole square. This is the alternative formula which we will be using it. Note, the correlation coefficient R numerically does not exceed unity. So, it should be lying anywhere between -1 to +1. So, what is +1 represents? If R is equals to +1, the correlation is perfect and positive. And if R is negative, the correlation is perfect and negative. It is negatively correlated. Whereas, if R is equals to 0, then there is no correlation at all between the two variables. These are the two things which you have to remember. Supposing while calculating the R value, if it comes as 1.03 or 0.4, also it is not acceptable, because the value is varying between -1 and +1. Anything between -1 and +1, if it comes, it is acceptable. Otherwise, we need to check back. So, let us see the problems. Calculate the coefficient correlation for the following data. X is 92, 89, 87, 86, 83, 77, 70, 63, 53 and 50, and y values corresponding to that is 86, 83, 91, 77, 68, 85, 54, 82 and 37, 57. These are all the values corresponding to x and y, that is two variables. How they are correlated, whether they are positively correlated or negatively correlated, and how best they are correlated, we need to find it. The formula, the solution is R is equal to summation xy divided by root of summation x square into summation y square, where capital X is given by x minus x bar and capital Y is given by y minus y bar, and x bar is sigma x by n and y bar is sigma y by n. And from the data, sigma x is 750 and sigma y is 720, and total n is nothing but number of data we have taken, that is 10. So x bar is 750 divided by 10, which gives us 75, and y bar is given by 720 divided by 10, that is y bar is 72. Now let us look into the table. So in the table, what and all we need to write, it is required for us is x summation is required, y summation is required, x square, y square and xy. All this summation is very much required. So, but this x and y is the given data from where we have to choose. But what is x? X minus x bar, where x bar is 75. So, from each of these values we need to subtract 75. Let me show you. See, 92 minus 86, right? Sorry, 92 minus 92 minus of, not this value, it is 92 minus of 75. So 92 minus 75, if you do, it will be 17. Similarly, 89, the next value will be 89 minus 75, which gives us 14. So this is what has been written. Next is 87 minus 75, which gives us 12. 86 minus 75, which is 11. 83 minus 75 and 77 minus 75, which is 2. 70 minus 75 minus 5. 63 minus 75, which is minus 12. 53 minus 75 is minus 22. 50 minus 75 is minus 25. We need to do the total of all these values. Similarly, for y, capital Y, how it will be found is the actual data of y should be subtracted with 72. That is, y bar is 72. So when we subtract y bar, that is 86 minus 72, which is 14, 83 minus 72, which is 11, and so on. This is how y is calculated. Next comes x square, that is 17 square. What is 17 square is 289, and 14 square is 196, 12 square is 144, 11 square is 121, and so on. So up to the last we have done. Next, y square. Similarly, 14 square is 196, then 11 square is 121, and so on. We have done it. Next comes x into y. So multiply these two columns. That is 17 into 14 is 238, and 11 into 14 is 154, and so on. So all these, once we calculate all these, we need to take the sum of these columns. That is x square, y square, xy, capital Y, and capital X. That I am writing it in the next slide. Please look into it. So summation x square is this, summation y square, and even x and y is also not required. Summation x square, summation y square, and summation xy. So the formula for r is given by summation xy divided by summation x square into y square. So that gives us r is equal to plus 0.7415. This is the value of r we have obtained. Next problem, calculate the correlation coefficient for the following data. So these are all the values of x and y they have given. So 78, 89, 97, 69, 59, 79, 68 and 57. And y values are 125, 137, 156, 112, 107, 138, 123 and 108. So let us look into the formula. R is given by, this is supposed to be capital X, sigma of capital X by capital Y divided by sigma of x square sigma y square. This has to be capital X. So what is capital X here? X minus x bar, and y is y minus y bar, where x bar is root x summation x by n, and y bar is summation y by n. From the data, we have taken sigma x is 596 and sigma y is 100 and n value is 8. So let us calculate what is x bar and y bar. So x bar is given by 596 by 8, that is 74.5, and y bar is given by 1006 by 8, which is 125.75. Now let us go to the table. So as we did in the last problem, we are doing the table here also. That is x and y, just for our reference, it is not calculated. Even this x sum also not required, y sum is also not required. Only we require is x square, y square and xy, right? So let us subtract from each value of x, as I have explained in the previous problem. How it has to be done is, you can see this. 78, the first value I am doing, this is 78 minus of 74.5, minus 74.5. which gives us 3.5. So this is what has been written. Similarly, 89 minus 74.5, which is 14.5, next 22.5 and so on we are getting. Similarly, y values are calculated. That is 125 minus 125.75, which gives us minus 0.75, and this will be again calculated. And as usual, we will do the x square, y square and x into y. So what is x square? 3.5 into 3.5, that is 12.25. 14.5 whole square is 210.25 and so on. So once we do this one, the total of this x square is required. Similarly, total of y square and summation of x, y, or total of x, y we need to do it. So x into y, that is this column into this column, if you do, we will be getting the last column, that is x into y. Now by taking all this values, we are going to substitute in the formula of r. That is x square total is 1368, y square total is 2055.5 and xy total is 1591. Let us substitute in the r formula, which is given by 1591 divided by root of 1368 into 2055.5, where r will give us 0.9490. This is positive correlation and highly positively correlated, we can say. Next problem. Calculate the Pearson's coefficient of correlation for 10 students who obtained the following percent of marks in mathematics and chemistry. So, student number 1 has scored in mathematics 78 and in chemistry it is 84. Similarly, student number 2 or roll number 2 has scored in mathematics 36, in chemistry 51 and so on the data. So up to 10 students we have taken, or roll number 10 we have taken the marks of 2 different subjects, that is mathematics and chemistry. It has been tabulated. Now what is the correlation? Whether the one who is studying in mathematics is good, means whether he is good in the chemistry also, or vice versa. If he is good in mathematics and bad in chemistry, or vice versa, if you do, it will be negatively correlated. Supposing if a student is good in mathematics as well in the chemistry, then it is positively correlated. Or we have to look into this data completely, thoroughly you have to study and calculate whether these students' marks are positively correlated between the 2 subjects or not. We have to check it, and if that is the case, what is the correlation coefficient? So x with the marks in mathematics and y with the marks in the chemistry. So r will be capital XY, summation of this XY, as I told you already, sigma of capital XY divided by root of sigma x square into sigma y square. So what is x bar? X bar is root sigma x by n, and y bar is sigma y by n. So summation x is given by 650 and summation y is 660 and n value is 10. Therefore, the x value will be 65 and x bar is 65 and y bar is 66. So let us go for the tabulation. As I have already explained, so 65 is the x bar and 66 is y bar. So we will have to subtract the mean of x and y in each of these values. So 78 minus 65 gives 13 and 36 minus 65 gives minus 29 and so on. Similarly, from each of these y values, that is 84, 51, etc., we need to subtract 66. That is 84 minus 66 gives 18 and 51 minus 66 gives minus 15 and so on for all the values. Then calculate x square, that is 13 square is 169, 29 square is 841, which is minus of course, and when you square it, it will be positive. So the values are calculated. Even the y square values also will be calculated and xy also will be calculated. So we need to do the sum of the last three columns, that is sigma x square, sigma y square and sigma x y. So these three columns we need to do the total of. Once we do the total of this, we will be getting x square as 5398, y square as 2224 and xy is 2704. When we substitute in the R formula, that is sigma xy divided by root of sigma x square into sigma y square, which gives R value is 0.7804. Thank you.